Hi, right now I'm going to talk for a little bit about the normal distribution. So this is compared to some other distributions you will see. You may see one where all the data is over here and the tail goes off that way. We'd say that's skewed right. We may see all the data over here and the tail going off that way and say that's skewed left. There are some distributions where there's data just all over the place, multimodal. But today this is all about the normal distribution. So when you see a normal distribution, you will find the mean, the median, and the mode all right here, right in the center. It's a part of what it means to be normally distributed. Most of the data exists in the middle. There are then data that head off towards these extremes over here, but not a lot of it. So if we took all of the students in your classroom and we lined them up shortest to tallest, we'd find most of the kids somewhere in the middle, sort of close to this average. We'd find some kids that are taller, some kids that are shorter, but the farther we get from the average, the less common some of those heights on the end become. We can actually calculate, if it falls normally, how much data is going to be a certain distance from the average. So if we calculate what we call a standard deviation, something I consider to be the average distance from the average. If we look for data that is one standard deviation away from the mean, we'd say it's about here. This is +1. And if it's over here, this is somewhere around -1. And we would say that 68% of the data fall between these two lines. If we go out just a little farther, we're out here about, we're at +2 standard deviations. If we're out here, we're at -2 standard deviations. And between them, we are going to find 95% of the data. That's a lot of data between those 2 points. If you go an entire another standard deviation away on each side, we come out here to +3 and out here to -3. Between these 2 lines, there is now a total of 99.7% of the data. That's a lot of the data. Very little outside of +3 and -3. Let's take a second and look at how to calculate that standard deviation. So if you have a set of data, let's say you have the height of every student in your classroom, and you take the average of that data, right? We add them all up. We divide by however many students that there were. We now have that average. If we take the average and we subtract the average from every person's height, we have the difference between those heights and the average. And one of the really interesting things is if you added all those up right now, you get 0. Because it's the average, that's one of the things about the average. If you subtract it from everything, right, there are about as many above and about as many below and about the same distance between them. If you take the distances from the average and just subtract them right there and add all those up, you will get 0. So to correct for that, what we do is we take those differences. So we have the score x minus the average. We'll call that the mean. We take those differences and square them. We sum all these values. We then divide them. By n-1, and we'll talk about y in a second. And we take all of this and we put it under a square root. right? If we sum a bunch of things and we divide by the number of things, that's like taking the average. Here, we're taking the difference between a score and the average. We're squaring it and square rooting it, so those sort of undo each other, right? With that purpose to avoid the fact that we sum them all to 0. But we're finding basically the average distance of the average from the average. Now, the reason that we take n minus 1 is that if I told you the average of something, and you gave me, let's say I told you the average of 10 scores. If you gave me if you gave me 9 of the scores, I could calculate the last score every single time. That score has no room to vary to give me the average that I expect. Whether it's a score that falls in the middle or falls in an outlier, it has to be whatever it is to give me the particular average that we're expecting for this set of data. Another thing that you'll find falls on averages are SAT scores, but those are designed that way. They want 500 to be the median, the mean. They want 800 to be the max score and 200 to be the min score, right? 300 above and 300 below. So most students are going to find that they fall plus or minus 100 points from that average from 500. And the standard deviations, I believe, fall about as expected to find 100 points higher about 2 standard deviations. So then, what did we say? 95% of the students. And then if we go out 3 standard deviations, we will find 99.7% of all students fall within those scores. There are a couple of related topics that we'll talk about in other videos, but I hope this has been helpful.